This video introduces arithmetic sequences. An arithmetic sequence is a numerical sequence where the differences between two consecutive term values are always the same. So let's look at a couple examples down here. Here's an arithmetic sequence that's increasing: 5, 9, 13, 17. So the consecutive terms, the difference between them each time is positive 4, right? It goes 5 plus 4 is 9, 9 plus 4 is 13, 13 plus 4 is 17. All right, look at the one that's decreasing. So the initial value here is 20. Then they're adding negative 3 and get 17. They're adding negative 3 and get 14. Adding negative 3 and they get 11. So those are both examples of consecutive term values always being the same. So an example of just a numeric sequence that would not be arithmetic would be something like this. Let's say you had 7, 11, 16, 22, right? Well, what's going on here? When you go 7 plus 4 would get you 11, right? But now, 11 plus 5 gets you 16. 16 plus 6 gets you 22. That is a numerical sequence, but it is not an arithmetic sequence. Some notation here. A lot of times for arithmetic sequence, we use the lowercase a sub 1, a sub 2, a sub 3, a sub 4. All that means is a sub 1 is your first term. So a sub 1 equals, the value is 5 on the first example here. On the second example, our initial value, the a sub 1, is the 20. And then if I say a sub 3, I'm talking about the third value. A sub 4, I'm talking about the fourth value. So this a sub 4 equals 17 in the first example. That's the value of the fourth term. The a sub 4 in the second example, that is the fourth term value is 11 on the decreasing arithmetic sequence. The common difference is found by subtracting two consecutive terms. So first time I kind of showed you what I was adding each time. But when we find the common difference, we're going to take the A4, for example, 17, and we're going to subtract 13 from it. So you take the A4 minus the A3, the fourth term minus the third term. Or we're going to take the third term, 13, minus the second term, 9. 13 minus 9 is also 4. Or we're going to take that second term, 9, minus the first term, 5, and we're going to get 4 there as well. So that's how we come up with the common difference, 4. Decreasing one, the same idea, right? So 11 minus 14, negative 3. 14 minus 17, negative 3. 17 minus 20, negative 3. So our common difference is negative 3. Once we know our common difference, we can then keep generating more values for the sequence by simply adding that value to the previous number. So our A4 was 17 on this first example, plus 4 would be 21. So our A sub 5 is 21. Our sixth term in the sequence would be 21 plus 4, which is 25. Same thing with the one that's decreasing, right? 11 plus negative 3, our fifth term value is 8. 8 minus 3, or 8 plus negative 3, is going to be 5, and so on. Let's do some more examples, make sure you got this. It's kind of a check for understanding. If you want to pause the video and write these down on a piece of paper, and then you can check your answers, that would be great. All right, this first one, we're going to go 19 minus 13 is 6. 13 minus 7 is 6, so our common difference is 6. Let's generate the next three values, next three terms and their values. So 7 plus 6 is 13, 13 plus 6 is 19, 19 plus 6 is 25, 25 plus 6 is 31, 31 plus 6 is 37. All right, let's look at the next one. 95 minus 97 is negative 2. 97 minus 99 is negative 2. Our common difference is negative 2. 95 plus negative 2 is 93. 93 plus negative 2, 91. 91 plus negative 2, 89. Let's look at the next one. Ooh, we got decimals here. So 25 minus 27.5 is negative 2.5. Okay, 27.5 minus 30 is also negative 2.5. So our common difference is negative 2.5 this time. All right, 25 plus negative 2.5, can't talk, is 22.5. 22.5 plus negative 2.5 is 20. 20 plus negative 2.5 is 17.5. Uh-oh, last one's got fractions. We can handle it. 1/3, 2/3, 1. So 1 minus 2/3, well, 1 is really 3/3, right? So 3/3 minus 2/3 gives us 1/3. And then 2/3 minus 1/3 also gives us 1/3. So our common difference is 1/3. So my next value is going to be 4/3, 5/3, and then I'm going to add another 1/3 to that. I get 6/3 or 2. Okay, I could also wrote those as mixed fraction, right? Mixed number. So it could have been 1 and 1/3 for the 4/3. It could have been 1 and 2/3 for the 5/3 if I wanted to. Now we can represent arithmetic sequences with words, tables, and graphs. So here's a context with words. Sarah has $5 in her savings and plans on saving an additional $4 per week. So our arithmetic sequence is 5. Oh, my pen's not working. 5, then plus 4 is 9, plus 4 is 13, plus 4 is 17, plus 4 is 21. Now, we could put this in a table, right? Where the first value in the table is a term number, term 1, 2, 3, 4, 5. That'd be like our a sub 1, a sub 2, a sub 3, and so on. And then the value, right? There's the 5, there's the 9, there's the 13, there's the 17, there's the 21. So it can be represented in a table. Now we can also put it on a graph. Okay, if we put it on a graph, we have discrete points because the x-axis, or the horizontal axis, if you will, is the term number. So term 1, term 2, term 3, term 4, term 5. Right? You can't have a partial term. So those are term values. And then the vertical axis, or the y-axis there, would be the actual value. So you can see there's term 1, there's the 5. Term 2, there's the 9. Term 3, there's the 13. Term 4, there's the 17. Term 5, there's the 21. Here's some more context. Mike has $20 on his Starbucks gift card and spends $3 per day on his drink. All right, so what's going on here? He has 20. Then he buys a drink, he's down to 17. He gets another drink the next day, and he's down to 14. And then he's down to 11. And then he's down to 8, and so on until he has no money left on the card. So on this one, you can still see our table again, term number with the values there. And you can also see the representation here with the graph, right? 20 is our first term, 17 is our second term, 14 is our third term, 11 is our fourth term, and 8 is our fifth term there. Now, the key thing here is the graph of an arithmetic sequence will always be discrete because that term values are always positive integers, right? It starts at 1. 1, 2, 3, 4, 5. There's no 1.5. There's no 0. There's no negative values. It's just going to be your counting numbers from 1 on up, okay? And the graph will always be linear. Right, this one is decreasing. The previous one we saw was increasing. And the reason for that is that idea of the common difference. So it's going up or going down by the exact same amount each time. It has this constant rate of change, which is why arithmetic sequence graph will look like a line. It's linear. Let's do one together. Again, if you want to pause the video and do this yourself, you may do so and then check your answer. Sally loves to read books during her summer breaks from school. Sally read 3 books her first week of summer vacation and plans on reading 2 more books per week. Create the first 5 terms for the arithmetic sequence represented by this scenario. All right, so she starts off, she read 3 books, gets summer vacation started. Then she goes, okay, that was probably a little too much. So now she's going to do about 2 books a week. All right, she wants to do 2 books a week. So plus 2 5, plus 2, 7, plus 2, 9, plus 2, 11. So our common difference here is 11 minus 9 is 2. 9 minus 7 is 2. 7 minus 5 is 2. 5 minus 3 is 2. So it's positive 2 is our common difference. Again, we put this in the table. Our first term is 3, 5, 7, 9, 11. And we can graph it. So the first term, we're going to go up to 3. Hard to see on my screen. I'll try my best here. And then the second term is 5. And then the third term is 7. Fourth term is up to 9. Fifth term is up to 11. So you can see it's increasing, it's linear, and it's increasing by that constant rate of change, which is the common difference of positive 2. All right, one more. Sanjeev has saved $300 to buy his friends, I should say friends, birthday presents over the next year. Sanjeev has lots of friends, so he wants to limit his spending to $25 per gift. Create the first 5 terms for the arithmetic sequence represented by this scenario. All right, so he has 300 bucks. And he buys somebody a gift, he's down to 275. He buys another gift, he's down to 250. He buys another gift, he's down to 225. He buys another gift, he's down to 200. All right. So what's my common difference here? It's negative 25. So again, we start at 300, 275, 250, 225, 200. All right, let's graph it. So for the first one, it's at 300. And you notice I got the axis scaled already for this. Then the next one's at 275, then 250, and then 225, and 200. There you go. So again, it's discrete, it's linear, but this time it is decreasing because our common difference is negative. Hope that helps. Thanks for watching.